Hi, we are from Group 36 from the database cloud security. My name is Teng and our group members is Akid and Rohit. So first of all, we will present our assignment project part one, which is the task one, which in this section we include the objective. So what we develop actually we develop a sport equipment rental system in a web base, and the proposed design we have is the user register and login, user dashboard, which include the browse, scan, return equipment, and the admin dashboard include the add, remove equipments, and manage all the rentals. So for the next one, I will talk about the proposed hardware, which what we use. So for the front end, we're using the HTML, CSS, and JavaScript for the UI. And for the back end, we're using the Python and also the MS SQL. For the Python, we're using the Flask frameworks. Next is this is the database design that we did. So this is the overall design of the database, and this is the system design. So the next one is the database security using the SQL, which we have divided into the role-based access control for the first one, and the next one is password security, which we're using the encryptions, input validations, backup and recovery. And so that is for the database security measure that we use. So the next one I will pass to Rohit for talk about and present about the implementation.
Hello, sir. My name is Rohit. I'll be talking about the implementation part. So, in the beginning, first is the Flask app initiation. So, you can see the code over here. The code sets up a Flask app by importing necessary modules for web handling, database connection, and password hashing and input validation. It then creates the Flask application instance to manage web requests and routing. And then after that, we go to database connection. And then the following code defines the connection string to connecting a SQL Server database using the ODBC driver. So after that, it's the login. Over here, where you can see the code, the login route handles user authentication. So when a post request is made, it retrieves the email and password from the form, hashes the password using SHA-512, and checks the database for a matching user with the provided email and hash password. So let's say, for example, if a user is found, their ID and role are saved in the session to track login status. Depending on the user's role, they are redirected to either the admin page or the user dashboard. If no match is found, an error message is shown and the login page reloads. For GET request, it simply renders the login. For the register part, the register route handles new user signups. On a post request, it collects and streams input data and then performs basic validations. The route then checks the database to prevent duplicate email or student ID registration. If the user is new, their details are inserted into the database and they are redirected to the login page. So for the admin page and the add equipment page, this admin, you can see the code over here. The admin route controls access to the admin panel, allowing only logged in users with a valid session. When an admin submits the form, new equipment details are inserted into the database and a success message is shown. On every request, it retrieves all equipment and recent rental records by joining user, equipment, and rental tables so the admin can view inventory and rental activity. The database is properly open and closed to ensure smooth operation. You can see over here. So for the edit equipment part, this route handles updating existing equipment details. It receives the equipment ID and values from when the user submits a form, and then it runs an SQL update query to modify the corresponding record in the database. After committing the changes, it closes the connection and redirects back to the admin panel. This lets admin like to edit the inventory items. For the rent equipment use case, it lets logged in users to rent equipment. It checks if the user is basically authenticated via session and retrieves the request quantity. It then verifies there's enough stock available. If not, it will return an error. If there's enough equipment, it will insert a new rental record with the rental and the due dates. After the changes, it closes the connection and redirects user to the dashboard. So for the return equipment part, this route handles returning rental equipment, and it fetches the equipment ID for the given rental record, marks the rental as returned by updating the return flag, and increase the equipment available quantity by 1. After committing the changes, the database connection is closed. I think that's it from my part, and I'll pass it to Akid for task 3.
Hello, my name is Akid, and I'll be talking about threat modeling and PDPA. So for threat modeling, the threat modeling, we address key risks such as spoofing, and the spoofing is mitigated through hash password login. Tampering is controlled with role-based admin access. Repudiation is managed via audit logs. Information disclosure is limited by restricting sensitive data to admins. DOS attacks are handled by limiting MS SQL connections, and privilege escalation is prevented through strict access control. And next is our threat modeling. As you can see, spoofing has the threat score, tampering, repudiation, information disclosure, denial of service, and tabulation of privilege. And on the left is the risk of what could happen. And I will continue to PDPA. So under PDPA 2010, roles include data user, such as admins who manage data subject, such as students whose data is collected, and data processor, the backend using Python and MS SQL. So to comply, this is all the PDPA requirements, the lifecycle stage. So to comply, we show a privacy notice during registration, collect only needed data, process it to post login, encrypt passwords, restrict database access, share data only with consent, remove inactive data, and securely delete trash. Without doing this, we are considered non-compliant and can result in fines up to 300,000 ringgit or 3 years imprisonment. And yeah, we don't want that. So next is task 5, the security measures and implementation.
Alright, for the next one, I will talk about the security measure implementation. And the first one we did is the input validation, which for this input validation, we're using the flux. When the user register or the login, we need to make sure that the input inside the field of the input is not having any of the SQL injections and so on. So for that, we will validate each of the input before we send it to the database or accessing the web database. We want to make sure there is no any SQL injection for that. So this is the example of the validation code. Then I will pass to the next one for the hashing password.
We also use hashing password in our system. So basically, you can see the code over there, which shows that the code is hashed using Shah 512, converting it into a secure fixed length binary before storing it. So this one basically protects the password from being exposed if the database is compromised, like brute force attacks and something. While Shah 512 is strong. Using specialized password hashing methods like Bicrypt or Argon tool with salting is recommended for better security. So as you can see the picture over there, this is how the password appears in each column in the database. I think next is database audit.
For audit, an audit is actually it tracks the database and schema access along with fake logins. It helps monitor and secure the SQL server environment by recording who tried to access which database object. So this counter measures repudiation and allows administrators to detect unauthorized access or suspicious activities. The images below are the queries to implement the audit into the database, and you can see the result of the audit logs. So yeah, basically that's it for our system and every security measures we've taken on the database. Okay, so now I'll be demonstrating the system. The first page is the login page, and if you're a user, you need to register an account. Let's try and put the new user credentials. Shah Iskandar 1212 at student. W.Sugathedasa. The password, the minimum password you need is 6 characters. Xuan just put 4 characters in. Yeah, it shows a flash showing you need at least 6 characters. Let's enter the credentials again. Register. And it redirects you to the login page, so you can log in now. This is the student dashboard. You have rentals and you can browse the equipment that's in the inventory. So for the rentals, let's view. No rentals have been made by this student, so it doesn't show any. Let's go back and look at the equipments. These are the available equipments and the quantities. So let's say we want to play basketball and we want to rent 3 of them. There was 13 just now, and it updates into 10 actually. So let's go back and view the rentals. See, the rental has been made and it shows the due date of when Ahmad should return his basketballs. In this direction, the button to return, to mark the basketballs have been returned. Now let's try log in as admin. Okay, so here in the admin panel, you can add new equipment. Just enter the name, category, and quantity, and press add equipment to update it into the database. You can also edit the existing equipment. Let's say the university decided to buy 3 more tennis rackets. You can see it's been updated. So here it also shows the recently rented items by the students and the status if the item has been returned or not. Let's try and log back into Ahmad's account. And let's return the items he has rented. We can check the basketballs now. It's to 13 again. Then we can look back at the admin account. It shows the status of the basketballs have been returned by Ahmad. So yeah, that's it for our system.